Hello students, as you all know that we have started the videos on Laplace Transform. In that this is the second video. Here we are discussing pole and zero in Laplace Transform. You know that any Macedonian signal is given by Hs is equal to Ns divided by ds. Or Laplace transform of any signal is given in the form of ratios of two polynomials or non-polynomials. Numerator can be a polynomial or in non-polynomial form, and denominator can be in a polynomial or non-polynomial form. So what are the poles? So first we will see the definition. After that, in the example we will explain, you will get understanding about this definition. So poles are roots of ds. These are roots of this ds. After common factor cancellation, which makes this hs tending to infinity, it is denoted by cross in S plane. So this is the definition of force. Now let us see the definition of zeros. So here the zeros are roots of ns. These are roots of this numerator. After common factor cancellation, which makes hs, this hs equal to 0, it is denoted by bubble in S plane. So here to understand this definition we should take one example, and one thing is that poles and zeros are nothing but the s values. Now these are the s values and we can represent them in the S plane. So let us take the example so you will have better understanding about it. So this is the example. Hs is equal to s minus 1 whole squared into s plus 2 divided by s minus 1 into s minus 4 s plus 1 minus 2 joule. So first point is after so we have seen here we have seen that after common factor cancellation. So that point is, so s minus 1 here and s minus 1 here is a common, so you should cancel it out, otherwise you will get 4 as 1 or 0 as 1. So that should not happen. So first you have to cancel out the common factors between numerator and denominators. After cancellation you will get s minus 1 into s plus 2 divided by s minus 4 s plus 1 minus 2j. So how to find the poles and zeros? So first we will concentrate on force. So for force you have to concentrate on denominator. So denominator is s minus 4 and s plus 1 minus 2j. So first to find the root you have to make s minus 4 equal to 0. So for finding a root of any equation you have to put that equation to 0. That's the same thing we have done. We have put s minus 4 equal to 0. So you have got s equal to 4. This is your first pole, which is indicated by sp1 equal to 4. So this is sp1 equal to 4. Second, s plus 1 minus 2j equal to 0. Again second equation, so you are going to equate it to 0, then only you will get the roots. So s is equal to minus 1 plus 2j. So this is your second pole. So now so the first thing is clear that poles are roots of the denominator, and this will make hs, poles will make hs equal to infinity. Now how this is hs? So here s minus 1 s plus 2 divided by at pole, that means if you put s equal to 4, so 4 minus 4 it will become 0. Or if you at second pole, that is minus 1 plus 2j, if you put it as minus 1 plus 2j plus 1 minus 2j, so this is also 0, which will make hs equal to 1 by 0, that is infinity. That's why we are the second condition is that second condition for the poles is that it should be no doubt it should be the root of the denominator, but it should make hs equal to infinite. So this is the I think you are clear about poles. So once again I will repeat it, that poles are roots of denominator, and that will make hs equal to infinite after common factor cancellation. Now let's move to zeros. For zeros, you have to concentrate on the numerator. So numerator, two equations. So s minus 1 equal to 0, also plus 2 equal to 0. So first 0 is z1 equal to 1, z2 equal to minus 2. So these are the zeros of our h's. Now this zeros makes hs equal to 0. How? Because if you put in equation of hs, zeros value is 1. So put s equal to 0, that is 1 minus 1. Put s equal to 1. Or another 0 is at minus 2. So s equal to minus 2 plus 2. So whatever may be at the denominator, it doesn't matter. Because 1 minus 1, 0, it is making it as, or minus 2 plus 2 is equal to 0. So it is making it as hs equal to 0. So what we understood that poles are roots of the denominator, which makes hs equal to infinite. Zeros are roots of the numerator, which makes hs equal to 0. So both these conditions should be fulfilled, that it should be a root and add that value of s, that means add that pole or 0. If it is pole, at that value of pole, hs should become infinity, and at that value of 0, hs should become equal to 0. So now in this video only we are going to see s plane. So this is here, s is a complex variable, that is sigma plus j omega. So in this sigma or damping factor is represented on x-axis and omega, j omega on the y-axis. So this is your s plane. So poles and zeros are represented on the s plane. So first we will see 0. 0 is at 1. So at sz1 is equal to 1. That is only a real part. So sz1 is equal to 1. Then sz2 equal to minus 2. So only real part, sigma is there. That's why sz2 is equal to minus 2. After that, sp1, that is pole. Pole is equal to 4. So here cross sp1 equal to 4. That is only real part is there, because imaginary part is not there. Second, in this pole there is real as well as imaginary. So that is sigma equal to minus 1 and this equal to 2. J omega equal to 2. So this cross point is here 4. So like this we can represent pole and zero in the s plane. So this is it for this video. Thank you.